Hi guys, Vigorous here with another quick chip update. So today we're going to be looking at the Combinator chip. If you don't know how to use the variable chip, watch my video on that first because we're going to be using that in this video. So here it is. This is our Combinator chip. We've got 3 input nodes, 1 output node. Now these input nodes are going to correspond to the left and right sides of the function. So in the case of addition, we have 3. This is going to be the leftmost, the leftmost side. This is going to be the rightmost side of the function. Let's take a closer look at what this bad boy can do. So we've got it in our configure menu now, and it looks like we've got 4 options besides addition. We've got some basic math functions. We've got subtraction, multiplication, division, modulus, and if you haven't done any programming, you're probably not familiar with modulus, but it's pretty simple, and we're going to go over it last. So let's start with addition. Addition is kind of a special case because it's the only one that has 3 of these input nodes, and there's a very good reason for that. With addition, you can loop it back on itself to hold a variable. So now anytime a variable comes into here, it's going to be held by that. So let's demonstrate that using our button over here. Well, let's wire this up. So the button's going to output a 1 every time I press it. And that 1 should be held by this variable. And we want to make sure that's what's going on by checking with an output chip. Output chips you can hook like anything up to, even if it's in the middle of a really complex system. It's not going to make anything wonky to hook up an output chip, so they're really good for diagnostics and troubleshooting. So let's go ahead and make sure the basics work. Great. Every time I press it, it is indeed going up by 1. But let's say we don't want it to go up by 1. Rather than that, we want it to go up by 3. We're at 9, so let's count by 3s. We can do that using a multiplication version of the same chip. So we're going to get that in front of us. Go to configure again, over here, press multiplication. So now, right side of our equation is going to be there. Or sorry, left side is going to be there, right side is going to be the green node. For multiplication, obviously it doesn't matter. So we want to multiply this signal by something, by 3. So we're also going to need a variable to hold our 3, or wherever you might get the 3 from. You don't have to use a hardwired variable going into these things. You can have something that's dynamically changing, so you can get this from a different point in your system. Doesn't have to be a hardwired variable. Never hard code the variable. So let's go ahead and look at that. So let's set that to 3. Wire up. Now, the reason this isn't going to cause us to get a runaway value from this output, even though we're getting a constant value from here, is because, get that on a multiple of 3 again, is because there's no input when the button's not pressed. So 0 times 3 is 0, so we don't get a runaway value issue. Let's hook it up and make sure we're counting by 3s. So now each time I press this, it should multiply the signal by 3, feed that into our combinator, which will hold it. And there we go. That works just fine. Let's take a look at the other 2 functions just real quick, just so we've gone over everything. So let's go to subtraction here. You can see it's gone all wiggy because subtraction is not supposed to be looped back on itself. That is not a function we have here. But let's say we take some hard-coded variables here. And 6. So we've got a 3 coming out of here, a 6 coming out of here. And 6 minus 3 is indeed 3. Let's change that to division. And now we're getting 0. Oh, sorry, I pressed modulus. It's like, that's not right. Now we're getting 2, because 6 divided by 3 is 2. And that leads nicely into modulus, actually. So you'll notice we got a 0 here. Why is that? What the frig is this function doing? Well, what it's doing is it's dividing these 2, and then it's giving you the remainder of that division. Now, that's useful for a lot of more complicated setups. We're going to be seeing more of modulus in the future. But for now, let's just show a really simple thing you can do with modulus. You can use it as an even-odd checker. Let's say you've got like an automatic door, an elevator that only has 2 floors, so it only has to go up and down. It only needs 2 states. We can use this to get a simple binary back and forth switching gate based on a larger variable. So let me show you what I mean by that. First, we're going to configure this for addition down here. So now every time I press this, if we wire it correctly, we're going to go up by 1. Next, we're going to get a 2 out of our red signal here. And make sure that's what we're checking against. So that's our 2. So now we're going to be dividing by 2, and we're going to be getting the remainder over here in this output chip. Let's get another output chip so we can see what's happening with that combinator on the bottom. And like I was saying before, doesn't matter that that's hooked up, we can still hook it up to other chips. So every time I press this, it's going to go up by 1. Okay, so we can't really divide 1 by 2, it'd be 1/2, but this is just going to give us the remainder, so it just spits that 1 back at us because it couldn't divide it even once. So our remainder is 1. When we get to 2, our remainder is 0. 2 divided by 2, remainder 0. And now, as you can see, as that number goes up, we're just switching back and forth between 1 and 0. So that's a really easy way to set up a simple switching gate. It's not the only way to do it, but it's my favorite so far that I found with the chip systems. So that's pretty much the basics of the Combinator chip. I'm going to show you how to do more with that binary switching output in a future video. Next up is the comparer chip, so stay tuned for that. And as always, thanks for watching. Have a nice day.